Ha! Take this!
Ha 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 ha! You fool! You'd never beat my formation.
You're probably wondering what this game is. Why is it so intense? What is it based on? Well, it is the hit game Periodic Chaos. I can tell you're interested. Don't worry, I, presenter, will explain how to play. The aim of the game is to beat your opponent through the use of elements. No, not fire, water, or those fake elements, but the elements of the periodic table. You draw cards, play compounds, and to beat your enemy. But that's just the basics.
Ha! Take that!
This is just a simple molecular structure. Weak. However, there are much stronger bonds that you can make.
Pathetic.
Now this is an example of strong bonding. This is ionic network bonding. Let me explain. This is sodium, and this is chlorine. On ionically bonding, these two make sodium chloride. This singular sodium electron is taken by chlorine, and chlorine becomes negative from having an extra electron, while sodium becomes positive after having an extra proton, or one less electron. Because opposite forces attract, these two become bonded and become sodium chloride. What makes ionic bonding stronger is that they can continue to pile up onto each other and make a network. And a network of ionic compounds can become a lattice. Take a look at this. As you can see, every positive ion is surrounded by negative ions, and vice versa. This creates a tight, strong bonding lattice. Ionic lattices create crystals. They have high melting and boiling points and are hard, but not the hardest. One of their weaknesses is that when a strong force hits it, they shatter.
Oh yeah? Well, how about this?
When enough force hits a network, it forces positive ions near positive ions, and the same with negative ions. If opposites attract, similarities repel. It repels the atoms away and the lattice falls apart.
My turn! Ha ha ha! Iron wall! What?
Another great bonding type. Metallic structures. Metals and alloys use a different type of bonding known as metallic structures. Positive ions are bonded together by a sea of electrons, making a different kind of lattice. This makes a tightly packed crystal lattice that makes them very dense. Because of the way they are bonded, metal atoms can slide past each other, making them malleable and ductile. The loose electrons cause metals to have a higher electrical conductivity. They also have extremely high melting and boiling points and are quite durable.
Dang it! What am I gonna do? Ha ha ha! Oh, you have an iron wall? Well, it's not as good as my diamond wall.
Diamond, the strongest material known to humanity, and a great example of the final type of bonding, covalent bonding. Covalent networks and lattices are the hardest and strongest of bonds. Similar to ionic networks, they create a lattice of interconnected atoms. However, there is one crucial difference. Every atom is covalently bonded to each other. These bonds are stronger than ionic bonds, which makes a covalent lattice like diamond extremely durable. You're probably wondering, what determines the type of bonding? Wait, you're not? You already know that metals and nonmetals make ions, and nonmetals with nonmetals make covalent bonds? Well, I guess you do know. Not! Prepare to have your previous knowledge thrown out the window.
Yeah!
Every atom on the periodic table has a range of attraction to electrons. As you go down the periodic table, it increases, and as you go across the periodic table, it decreases. This range is called electronegativity. The more electronegative an atom is, the more it attracts and uses electrons. This is what determined what type of bond between compounds. When two bonded atoms have a similar electronegativity, it is called a non-polar bond. This is because both atoms have a similar electronegativity and neither has more than the other. Hydrogen gas is an example of a non-polar compound because neither atom has any more electronegativity than the other. When one atom is more electronegative than the other, it can be non-polar. Water, or H2O, is polar because oxygen is more electronegative than either of the hydrogen atoms, and it uses the electrons of either hydrogen atom more than the hydrogen uses the electrons of the oxygen atom. The larger the difference in electronegativity, the more likely that the bond is ionic. When one atom has an electronegativity of 2 or more than the other atom, it becomes ionic. Sodium chloride is a good example of this. Chlorine is more electronegative than sodium, enough so that it can steal the electron from sodium and keep it for itself, leaving sodium with one less electron and chlorine with one more electron. And there you have it, the explanation to periodic chaos. Hopefully you understand enough and are interested enough to buy the game. Let's go see how our players are going. Oh, they're gone. It must have taken so long that their game must have finished. Oh well, who won you ask? No idea! Thanks for watching. Don't forget to like and subscribe. Buy the game at this link, and until next time, I'm Prez Enter, and this was Periodic Chaos.